But seriously, most of the SLPs are just, there's so many different ideas and aspects, and they just all like totally thrill me to like see where they've gotten to, but also just kind of like see the progression from quarter to quarter, from like original idea to idea that can actually be implemented, and then in some cases, you know, an actual prototype of an early version. It's like really cool to see.
It'd be really cool to see if someone tried prototyping my project.
Yeah? Bless you. All right, so questions? How did PA3 work out for everyone?
I heard it works great. So
yes. So if you did not get it submitted right, I posted a note about 5:30 this morning on how to upload, because I was getting tons of emails from people saying I can't export, I can't upload. So there's a reminder there, but let's run through it really briefly here in Eclipse and just kind of touch base on the steps. And there's a few things to increase the chance that this process will succeed. So I'm in my workspace with tons of
folders and projects.
Yeah, tons of projects. So first thing is, all right, so let's just export waffles. So I'm going to open this project. So first thing is, make sure that you only have one project open. Okay, so if you have a little triangle next to your project, that project is open, which means you can click on it and you can expand these folders and so on. So whatever project you want to export, we're exporting waffles. If you right click, you can say close unrelated projects, and that'll close every other project. Okay, and closing, it doesn't delete or anything, it just closes it out, so it's not a project you're working on right now. So now I have one project open, that's waffles. Okay, right click again and say export, and under general you'll see something that says archive file. That's the one you want to use. So select archive file, go on to next. And before you click anything on here, you should observe that the two windows on the top, the one on the left has the name of my project, waffles. There should be a little check mark next to it. And on the right there should be two files, class path and project. They should have check marks next to them. And my suggestion, if that's not what you see, go back, right, close out of this, do the whole thing over again and see if you get to this. If you don't, good chance you're not doing something exactly the way that we want it done, and the archive may or may not work. Assuming that you see this, you only want to change one thing on here, which is the archive file itself. So I'm just going to browse, and I'll go to my desktop, and let's just call this we'll call it waffleexport.zip. I suggest you call it something other than just like, you know, temp.zip or zip.zip, so that you know if you see this file, this is actually the file you just created, so that you're not uploading the wrong one. So put in that name, just say finish. And that should leave you with your export file. And this you want to just push up to canvas, okay? But if you want to look inside it, right, you can look at what's contained in there. There should be a folder for your project, and inside there should be three files, right, class path, project, and a settings directory. And then there's a source folder that'll actually have your source. So that's what waffles says. Oh, chocolate chip and boysenberry. There, you're just talking about that. All right, but generally don't tinker with this zip file. Okay, it's in a format, it's in a particular structure that is meaningful to Eclipse, so when I try to import it, it will give me a project, as opposed to if you just give me your .java file in a zip, I'd have to create my own project and so on. Okay, so if you want to go the extra distance and check this to make sure that it actually worked, first thing you want to do is rename your project, okay, or delete it. Don't delete it. Right? So let's rename it, because if I already have a project named Waffles and I try to import that file, it'll say, I can't import this, Waffles already exists. Okay? So I'm going to rename this to basically get it out of the way for the import test. So on this system, I'm just going to say right-click and rename. On some versions of Eclipse, you say right-click, you have to say refactor, and then refactor has an item that says rename. So rename that, and I'll just call this Waffles Yum. And so now I no longer have a project named Waffles. Okay, before I import, I'm going to close this. And if I had other projects open, this would say close unrelated projects. So no projects open anywhere. Okay, so here's how we import. Go to File, Import, and under General, do Existing Projects into Workspace. Don't do Archive File. Existing Projects into Workspace, Next, and then you have to change this radio button to say Select Archive File, and then just browse to the name of the archive you created. So we'll go to the desktop, we'll do Waffles, Export, and it should look like this. You should see your project name should have a checkbox next to it. If you got that, just say Finish, and it should bring it in. And there's our Waffles project. And we can run it. There we go. All right, so if you didn't get it exported in time, right, bundle it up right after class and push it over. All right, so any lingering questions with PA3? My plan is to start grading midterms this weekend. I'll definitely get through those by Monday. If I get through them before Monday, I'll start working on PA3, but PA3 may be a few days. Midterm should be on Canvas by sometime Sunday at the latest. So let's go on to PA4. So PA4 is this 20 questions game that we talked about a little bit last week. And the direction of this game is the person running the program thinks of something, the computer tries to guess what you're thinking of. Okay, don't code it up the other way. So the computer's trying to guess what you're thinking of. And it does this by asking a series of yes-no questions. And we're not limited to 20 questions, although that's the name of the game. So we talked about decision trees, right? Binary tree, yes takes you to the left, no takes you to the right. And depending on what's in this tree, the computer will ask different questions in response to your answers. And hopefully when it gets to the end of a path of nodes and it gets to a leaf node, that's an answer. Hopefully that's the thing that you're thinking of. So let me show you what this looks like, and then we'll start digging into the details. And the hairiest detail of this is the database file. Because the idea is after you finish playing this, the decision tree should get written out to your hard drive. So that if you exit the game at that point, come back later and play, it starts off where it left off. And it knows everything that it learned up to that point. And I have given you a sample decision tree under /temp called 20qbig.txt. And 20qbig has about 20,000 questions and answers in it. So this was a crowdsourced database. A student who went to UW was given this for an assignment they had to do and said I could use it, so we've got it.
Are you going to keep hitting yes?
Yeah. So this has interesting questions, and I don't know what all is in here, but hopefully it's
Duck?
nothing bad. Does it have blue around its eyes? Does it have a large bowl-like bill?
Change forms 5 times.
Does it change form 5 times? That's a good one. It's an EV. Yeah. Does it have a weird-looking bill? Is it from Alien Planet? Oh, I saw the Boogie Monster.
This is getting interestingly weird.
Yeah. So this was crowdsourced, and whatever people decided to put in there, that's in the database. So we're not sure what you might find in there. So let's see how this plays. So one thing before we play this, when you run this, the name of the database, you can build that into your code so that it always uses a database, say in your home directory or something like that. But you want to give the program the option that if the user runs it with a command line argument, that's the name of the database it's going to use. It's going to read from that and it's going to update it. So in Eclipse, right, so from the command line we could just say Java space, name of my program space, database name. Okay, from Eclipse, if you want to specify command line arguments, you got to do a little bit of point and click. So I've got my project open. I'm going to right click and I'm going to say properties. And under properties, down here close to the bottom, there's going to be run debug settings. I'm going to click that, and it should show me one launch configuration, which is probably the name of the project itself. So I'm going to click on that and I'm going to say edit. And then the second tab over here says arguments, and this is where I can specify the name of a command line argument. Now, I'm not going to specify a command line argument because my built-in database is that big 20,000 line database. But then we'll come back and we'll specify a local database to play with. All right, so let's go ahead and run this. So what object should we think of? Or who wants to think of a animal? Okay, you got one in mind?
Yes.
Okay. Can it fly?
No.
Okay. Is it a very small animal?
I'll say yes.
Some of these are subjective. Does it live in trees?
No.
Is it a type of dog?
No.
Does it build dams?
No.
Does it have a long tail?
Yes.
Okay. Is it native to Australia?
Clueless. I said lizard.
Let's say no. Does it eat cheese?
No.
But my lizard eats like fruit and bananas. Does it live in the Andes Mountains?
Where's the Andes?
South America, I believe. But maybe not.
Maybe.
Maybe. It's not specifically. Is it cold-blooded? Lizards are cold-blooded. Does it have fur?
No.
That would be weird. That would be a platypus. Can it climb glass walls?
Do they do that?
I think they do.
Does it depend on the lizard?
Yeah, it might be strange because we don't have a particular lizard in mind.
The too generic animal.
I think for a generic lizard, maybe put yes.
Yeah, I think so. Can it change color?
No.
No.
Aliens change color.
But it's a chameleon.
Could I find it in my garden?
Depends on if you have a lizard or not.
Depends if you have a lizard in your garden. I think this is thinking of a snake if we say yes. So let's say no. Is it green? Yeah, lizards are probably green. Is it native to Hawaii?
What?
Could be. Let's see what kind of lizard is native to Hawaii. Okay, I think I've got it. Is it a gecko? Well, that's a type of lizard. So, yeah, I'll say yes.
New
Cool.
project then. Make it 3 trees. Yes, no, maybe.
Yeah, so that would be a good embellishment, actually. A maybe or an I don't know.
Maybe if you post like maybe it takes you to a subtree that still points and sends you answers, but has a more.
Has a better question.
Yeah.
That could be good. Yeah, that'd be a nice embellishment. All right, so this is pretty good at guessing what you have in mind. So let's change this to use a smaller database. So I'm going to change that edit, and I'm going to arguments. I'm going to put in a full path. It doesn't seem to like relative paths, at least on my system. So I'm just going to point to a database file called test. right-click the project, Properties, run Debug Settings, select that one choice, say Edit, go to the Arguments tab, and then put in your arguments on top.
Debug settings.
Run Debug Settings, and then just edit the configuration and find the Arguments tab.
Okay.
And it's on the video. Alright, so here's the file that I'm working with for a database. I'm doing this under Windows, so I've got my little control M's on the end. I'm not doing it under Windows.
And somehow your program is able to read and discern questions from answers.
Yes. So here's the database format. Pairs of lines. The first line is either a Q or an A. If it's Q, the following line is a question. If it's an A, the following line is an answer. And we'll talk about how to create this file and how to ingest this file. But this file is very hard for you and I to just look at and understand what it's saying. Well, we don't have to understand what it's saying. We're going to tell the computer how to understand it. All right, so pairs of lines, questions and answers. And right now, this is our simple tree that we used the other day. So is it an animal? And if yes, then, I don't know, did I say pig or dog? It's pig. And if no, then it's a rock. So if we run this, first question it asks, is it an animal? And if we say yes, then it says, okay, I think I've got it, is it a pig? Okay, and let's say the answer is no. Then it says, what were you thinking of? So I was thinking of a dog. And then it says, please ask a question. Tell me a question for which yes means dog and no means a pig. I made my text big so it scrolls off the end here. So yes means a dog and no means a pig. So I'm going to say, does it bark? So now if we look at this file, it's gotten bigger. It has 2 questions in the top and then 3 answers after that. Is it an animal? Does it bark? Dog, pig, rock.
Interesting.
Like nested.
Kind of, yeah. So what happened? It guessed a pig.
And all R notation.
So, yeah. It guessed a pig and that was wrong. So it said, what were you thinking of? I was thinking of a dog. And then it said, tell me a question where yes means dog and no means pig. So it was building a little mini tree with the question, does it bark? And then it replaced this node with the root of this new tree that it made. So this is what our decision tree looks like right now. And if you play this as a human, is it an animal? Yes. Does it bark? No. It must be a pig. Yes, it must be a dog. Or is it an animal? No, it must be a rock.
That sounds like a simple addition to a tree.
Yeah, it is.
Just add to a leaf node.
Just adding to a leaf. So we don't have to worry about any of the weird stuff we did when we were deleting, for example, where we had to go back and find something, right? When we get to the end of the game, we're at the place where we're going to make the change. Okay, so that keeps things a little easier. So let's play this once more. So think of an animal, think of an object. Is an animal? Yes. Does it bark? Let's say no. I've got it. Is it a pig? No, it's not a pig. So what were we thinking of? We were thinking of Kermit, the frog. So we need a question for yes is Kermit and no is a pig. So what's a good question?
Is it a Muppet?
Is it a Muppet? Although there is a pig Muppet too.
To be fair,
But that's not.
Kermit, I don't mean to ruin childhood here, but isn't Kermit an inanimate object?
That's okay. How about, does it ride a bike? Because we know Kermit rides bikes. And I've never seen Miss Piggy on a bike. Okay, so now if we look at our database file, it's gotten bigger. And the composition of this file we can take as being kind of gibberish to us, because there's 2 questions, there's a dog, there's another question, and there's 3 answers, right? So don't try to manipulate this file by hand. Don't try to go down to the right spot where the question was asked and then insert some extra lines or something like that. I'm going to give you a much easier way to create this file and ultimately to ingest it. So our pig got replaced by a question, does it ride a bike? And yes is a Kermit, and no is a pig. All right, so there's 2 things we have to do. We have to take the decision tree that we're building and updating, and we have to write it out to a file. And then later on at some point we need to read back in from that file. Okay, so the writing part is the easier of those 2. So how do we write? Plain old node left right traversal. And that particular order is going to make it easier to read in this file. So this is like a plain old binary tree, but you probably want something in here that tells you for each node whether it's a question or an answer. We can do that by looking to see if the children are null. If it has no children, it's an answer, but you may want to put a flag in anyway. So I'm just putting question marks on the end of these things that to represent my flag, but let's just say this is a question, this is a question, this is an answer. I'll put them in parentheses. So you can have a Boolean in your node, question, and it's true if it's a question, false if it's an answer, or whatever you like. So what happens if we traverse this tree in node left right order? We start at the root. First thing we do is we write out the node itself. So it's a question, we're going to write Q colon, go down to a new line, and then write the question, is it an animal? That takes care of the N. Now we have to traverse the left subtree, node left right. So root of the tree is question, does it bark? And then we have to traverse the left subtree. So print out the node. There's an answer. It's a dog. Left subtree is null, nothing to traverse. Right is null, nothing to traverse. So for this circle tree, we printed out the root node. We traversed the left subtree. Now we have to traverse the right subtree. Traverse it in LR. So the root is a question. Does it ride a bike? Traverse the left subtree, that's going to be an answer, Kermit. Traverse the right subtree, that's an answer, pig. Now we've traversed the root, the left and the right subtree of this outer circle. We're done with the left subtree of the original tree. We did the root, we did the left subtree, now we have to do the right subtree, and that's just going to be answer, rock. So that's what we would have written into the file. And that's what the file actually has in it. As I peek to see if I'm telling you lies. Nope, we're good. So writing the file, pretty straightforward. It's just like the traversal we've been doing since winter for outputting the contents of a tree. Just do it node and then left and then right in LR. So pre-order. The other direction is a little trickier, ingesting this file. So we start off our program. First thing you want to do is open whatever the database file is, either the one you put in your code or the one specified by the first command line argument. And then you want to build a tree from a file like this. And it's a short algorithm if we do it recursively, like most things. So let's imagine a method called read. And let's suppose this returns a tree node. And one of the details for this is we want to open up a file in the beginning, whatever the database file is. We want to open that up in the scanner. We're not going to close that until we're completely done reading the file. So our read method, which is going to be recursive, should not open the file, should not close the file. It's just going to read. And the goal of read is whatever point you're at in the file, we want to read as much stuff as we need to read to create a tree from that point on down. So if we're sitting right here in the file where it says question ride a bike, this thing should return a node containing question ride a bike with 2 children, left child of Kermit, right child of Pig.
You said it doesn't open or close a file.
Correct. So you want to do that outside of your read method. You're going to do that, say, in your main program. And again, you got to put on your recursive glasses and think of this purely from a recursion standpoint. Okay? Because to write read, we're going to have to end up using read. So here's the algorithm. So read the next line of your file, which you've opened outside of this. Let's just call that type, so that's a string. And this is pseudocode. You got to do if type dot equals, etc. But if the type that you just read is A followed by a colon, this is an answer node. Okay? And our tree is going to be really simple. It's going to have 1 node in it. So if type is equal to A, make a new node. If you have a flag saying whether it's a question or an answer, deal with that flag to indicate that this is an answer. Read the next line, and that becomes the node's data value. So if we were right here at rock, we would have read this in. The next line would return rock, so this temp node's data value is rock. And then has no children because it's an answer. And then just return that node. There's 20 different ways you can code this, right? You might want to make a constructor that takes a string. Might want to make a constructor that takes a string and automatically puts that into the data value and then sets left and right to null. You could have 2 constructors, one for an answer, one for a question. All kinds of things you can do, but in terms of pseudocode, right? If you read a line and it says that you've got an answer coming, make a new node. Remember, it's not a question, it's an answer. Take the next line from the file, put that in the data, make sure there's no children, return that node. Otherwise, well, you could double check type and make sure it's a Q colon, because it should be either A or Q, and if it's not, you know the file's corrupt. And it's not a bad idea if you have the opportunity to sanity check the file. And that would tell you pretty quickly that you've got a file. It's not actually a valid database file. But assuming that the file type was actually Q, the line was Q instead of A, this is real simple. So, but I'll start it on a new page anyway. So in this case, make a new node. Record that it's a question. save the data from whatever the next line is that you read from the file. All exactly the same so far as for an answer. But now set the left child equal to the return value from calling read. So there's a recursive call. And then, what are we going to set the right value to?
Read.
Read. Good. And then return temp. And you don't necessarily have to believe this works to make it work. Right? But Monday I want to spend some time with you going to the board, first of all playing this game and updating the decision tree by hand, but then also playing around with some ingest and some output of the tree to the file and back, just to familiarize yourself with what this is supposed to do. And then once you know what this is supposed to do, coding it is pretty straightforward. It's easier than most of the things we've coded in here so far. The real challenge is sort of getting in your brain that this is the behavior that I'm after. And like I say, you don't have to believe it, but it's more comfortable if you believe it. But this is basically undoing the result of NLR traversal, right? So if we're at a leaf node, we're just going to read one line, right? That's where our NLR recursion hits the end and pops back up, right? Otherwise, we're going to read in the current node, and then this corresponds to the left traversal. Whatever we got from traversing to the left should be the next thing in the file. And if read is going to consume an entire tree's worth of lines from this file, it should pick up exactly that left subtree that was written. And now we're setting the root node's left child to be that tree. And then if you continue in the file where that left off, the next thing should be the result of the right traversal. That's another binary tree, and read should pick that up, and now we set the right child equal to that. And if you do this and it works perfectly, you don't even need to check for end of file. When this process exits, you should have just read the last line of the file. And it should just work out automatically. You should never run out of nodes. You should never have extra nodes left over. But, you know, if you want to sleep well at night, do the usual checks to see if you have a next line before you actually call next line and so on. And there's no looping in this, right? If it's an answer, just read the next line, return. If it's a question, read the next line, save that, and then just call yourself twice. So there's no while loops or anything like that. So in your main program, first thing you do when you run the program is you open up the database file, you go through this read process. That pulls everything in, creates the tree, and then you close that database file. And then you play the game. So print out the root node, which should be a question, get a yes, no from the user, follow the branch either to the left or the right, and so on. When you get to the end of a path and you're at a leaf node, it should be an answer. Tell the user the answer, find out if you were correct or not. If you're correct, nothing to do, you can just go back, play the game again. If you're incorrect, then you have to do the third weird thing about this project, which is update the tree. So you make a modification to the decision tree, and then when you're done, go through the whole NLR traversal and rewrite the database file. So every time that you finish the game and you learn something new, the file's updated on disk.
And it's printed out as if it were in by doing NLR traversal and saved to the file.
Correct. Right, so this is an NLR traversal of that large decision tree. And it starts with a bunch of questions and then has some answers, and then they sort of mix together.
That was only 1%.
Yeah, it's a big file.
Okay. That kind of looks much more logical.
Yeah. And I think it started off as a fairly balanced tree, but these trees, the balance depends on how the tree gets updated, which depends on who's playing it, what they ask, and so on and so forth. And there's no easy way to go through and rebalance this tree. So that's not a feature. But we don't care if it goes more than 20 questions. It usually doesn't. All right, so last piece. Let's go through the update of the tree. So is it an animal? Yes. Does it bark? Yes, it's a dog. No, it's a cat. And if it's not an animal, it's a rock. All right, so you're thinking of a snuffleupagus. So is it an animal? Yes. Does it bark? No. Is it a cat? No. Okay, so are you thinking of a snuffleupagus? Okay, so you get, I'm not going to spell snuffleupagus. Snuff. So you got the answer that the user just gave you. Put that into a node. You know the answer that you were thinking of before. That was a cat. So you've already got that as a node. Get a question that that differentiates the two. So is it large? And yes, snuffleupagus. No, it's a cat. Now we need to replace this node, but this potentially is a little tricky because, you know, this is going to be called temp, I think, if we're moving through the tree, right, or next node or something like that. If this node is called temp, we can't just say temp equals this new node, right? Because our goal is not so much to replace the variable pointing to this. Our goal is to replace this node's right child with this node.
So save the contents of the cat.
So you got to save.
The tree.
You got to save where you came from, right? When I get down to cat, if all I know is that I'm at this node, I can't really replace this node with this. I've got to know about the node before cat.
You have to have a previous.
So you got to have a previous and a next kind of deal, maybe. Or you can set it up to be doubly linked. This is the other option. You can have each of these things point back to a parent. And in that case, once you get down to cat, you need to change the parent's right child. Well, you can find the parent, just follow the uplink. And that's not a bad option here because we're not doing deletes, we're not doing any kind of adjustments other than at the leaves. So if you want to play around with a doubly linked tree, that's a good opportunity to do that. Either way, once you get back to the parent, you need to know, am I adjusting the node on the left or the right? Okay, so you could do that a few different ways. One way is to also remember which way you went at each point. Another way is you could just look at the right node and see if that's equal to the node you ended up at. Look at the left node and take whichever one matches. So there's a lot of different ways to code this. But ultimately your goal is take the previous node's right child in this case and point to this new tree that I just created. And so that happens at the end of the game if the computer guessed wrong. All right, any other details in here? Travel left, right. If you want to call your nodes yes, no instead of left, right, that's totally fine. That's probably going to be less confusing, or maybe not. Make sure your code's well commented, of course. Embellishments, you can do this however you like, okay? You can make this a straight command line thing like what I was showing in the demo. You can make this a full-fledged GUI with buttons for yes and no and, you know, a nice text box that shows you the question. You can put a history of the questions and answers on the side. You can have a counter that's telling you how many questions you've been asked so far. Totally up to you, okay? As long as it does these basic operations, plays the game, updates the tree, reads the tree from a file and writes the new tree back to the file. Those are the only fixed requirements. But you can have fun with this, right? If you get this part working early and you want to play more with GUIs, go for it. If you want to do this strictly on the command line, you can do this as a straight command line program, and then when you're ready to submit, just make a basic class in Eclipse and throw your code in there, and then export it and upload, or test it, export it and upload. So make your own tree class, your own class for doing the LNR traversal and reading it and so on and so forth. But you can use scanner, print, writer, string, all of those things that are built in. So suggestions for doing this. If you want to get something running sooner rather than later, build yourself a hardwired decision tree. Right, so in 222, when we started working with trees, one of the things we did on some of the early ODPs was we manually created trees. Right, create a node with a data value of 40, a left child which is a node containing 20, and a right child which is a node containing 60. Right, and you just malloc a bunch of nodes, set the data value, set the left value, set the right value. Right, you can do that in this case also. You can create a T node, set its data value to animal, set the question flag to be true, create a bark node, a rock node, a dog node, a large node, a snuff node, and a cat node. Load the data value, set the question or answer flag appropriately, and just make the left and right child point to the right thing. And now you got a decision tree to play with. So you're short-circuiting all of the file input, all of the file output, and you can ignore all of the update at the end. Just start with this decision tree and play the game. Right? Maybe make a separate method called play game and have it just go through the tree, ask the question, get the answer, follow it through. And it should be able to identify, 4 things correctly. And that gets you started, right? So you don't have the blank page syndrome where you're staring at the screen wondering where to start. This gets you started, gets you a lot of the code that you're going to have in the finished product anyway. And then you can start building on this. So maybe the next thing is to start thinking about how am I going to improve this if it's not a cat, right? But it was actually, some other small animal. How can I modify this to do this update of the decision tree? And you can develop all that without ever worrying about file I/O.
And you say that a doubly linked tree would be advantageous here?
Only in the sense of if you get down here and you need to change what large pointed to, say, on the right, if we're at this node, we can find our parent node by just following that link back up.
Yes, but in the sense that having a previous and a current node would be problematic in this point of view.
Nope, previous current works fine. Having back pointers for doubly linked basically is the same thing. If it takes care of the same thing you can take care of with the previous current. So if you like the previous current setup, you can use that. If you don't like that or you want to try something different, you can try putting back pointers so each node points to its parent. That also gives you the option of going backwards. If somebody says, oh, I messed up, I want to go back, you could pop back up the tree. So just one suggestion, right? Hardwire the tree first, play around with that, and then maybe think about how to extend it, and then you can switch over to doing the file I/O. Or, do the file I/O and then work on extending it. They're kind of independent. Other questions about this?
I recently made a different discussion. I basically asked a question about the difficulty of extending a binary tree into a
decision tree? Okay. They're kind of the same thing. Right, I mean a tree is just a node with children, and those children are nodes with children and so on. Binary just means there's 2 children, which is still the case here. The binary trees we worked with tended to be binary search trees, which means whatever information you're storing, if there's a sort order, things to the left of the root are smaller, things to the right of the root are bigger. And that doesn't apply here. But that only affected us because we were trying to do things like search or insert. And we're not doing any of those things here. So the basic structure is probably the same. You might want to add a flag to say if it's a question or answer or not. You might want back pointers or not. But yeah, the same basic structure is going to be the same, but it's going to be pretty much a pretty small subset of what we had in our binary tree classes. The answers are always on a leaf, so if you want to know if you're an answer, you can just see if you have any children. And if you don't, you're an answer. If you do, you're a question. So, or you could bundle that into a method called, you know, is this a question?
Of course, if you have a flag, you could also look at that.
Or you could have a flag and just look at that. So kind of like with the last few assignments, right? I'm not pinning down all these details. It's totally up to you. It's part of the creative freedom that you have as the coder. So there's a good sample 3-line, 6-line, 3-entity decision tree to start with. When I test your file, I'll never test it with an empty database. I'll always start with either at least that 3-line file or some other 3-node decision tree. So you don't have to worry about the edge case where the decision tree doesn't exist or it's empty. All right, good to go. Enjoy the weekend, and I will see you on Monday.